right, this is Mr. Gucci here with the second part of your final exam review for Unit 8. In the first part, I did constructor response questions 9, 10, and 11. This time, I'm going to do 12, 13, and 14. So let's get to it. Okay, so number 12, lithium hydroxide and iron 3 nitrate. All right, so does a reaction occur here? Let's figure it out. So I'm just going to copy this right here. Control copy. Oh, that's not going to work. All right, well, I'll just keep it on the other page then. All right, so what I've got here is lithium hydroxide. Okay, lithium hydroxide. Now, this is the word I need to put it into a formula. Lithium is Li. It's in the first column of the periodic table, so it has a 1 plus charge. Hydroxide is a simple polyatomic ion. It's OH with a 1 minus charge. So you don't even need to crisscross for lithium hydroxide because it's a +1 and a -1. The formula for lithium hydroxide is LiOH. Now, you don't need to put parentheses around the OH. I just like to do it. It makes it neater. All right, and in this problem, lithium hydroxide combines with iron 3 nitrate. Well, iron is Fe, and the 3 here means it's a 3 plus ion. And nitrate is a polyatomic ion you'll find on your ion list. Its formula NO3 with a 1 minus charge. So this one maybe we do benefit from crisscrossing. 3 plus means we're going to have 3 nitrates. 1 minus means we're going to have 1 iron. So the formula for iron 3 nitrate is Fe, and there's only one of them, NO3, 3. Okay? It's called iron 3 nitrate, not because there's 3 irons, but because iron has a +3 charge in this case. All right, so what do these things combine to form? Well, once again, lithium is a 1 plus ion, hydroxide is a 1 minus. Iron 3 is a DOI 3 plus ion, and nitrate is a polyatomic with a 1 minus. So I'm going to combine lithium and nitrate and iron 3 and hydroxide, all right, to make a new compound. So start with the easy one. Lithium, which is 1 plus, and nitrate, which is 1 minus. You don't even have to crisscross it. +1 and -1, they cancel out. So you just get LiNO3. And I like to put the NO3 in parentheses. Again, not necessary, maybe not even formally how it's done usually. I like to do it to keep track of my polyatomics. And the other thing we produce is Fe3 plus and OH1 minus. Crisscross, we get a single iron and 3 hydroxide. I don't know why, but I can tell you that this is where most students will mess up this problem. They will write it down like this. This compound has an iron, an oxygen, and 3 hydrogens. That's not what's going on here. What's going on is you have an iron and 3 hydroxides. All right, just make sure you get that down. Now we balance. 1 lithium, 1 lithium. 1 hydroxide, 3 hydroxides. So we're going to put a 3 in front here, okay? 1 iron, 3 nitrates, 1 nitrate. So we're going to put a 3 in front right here. And we did it. All right, boom. There we go. There we go. Let me clean this up a little bit. Now, there is one thing that we have to keep in mind. This is a double replacement reaction. And so for this reaction to occur, one of these guys here needs to be a solid, liquid, or a gas. So once again, I'm going to go to the solubility table. And our products were lithium nitrate. So let's see here. Lithium. Well, aside from phosphate, lithium nitrate. Nope, does not does not form a solid, liquid, or gas. So that's not going to work. The other thing was iron 3 hydroxide. So here's iron 3 hydroxide. Yes, iron 3 hydroxide is a solid. So this reaction does occur because the iron 3 hydroxide that forms is a solid. All right. And at least one of our products has to be a solid for a double replacement to occur. Let's do another one. All right. By the way, I know looking at this looks like a pretty big, messy bit of work to do here. If you want to come and see me to review this one-on-one, we can walk through it some more, okay? And if you want to spread this out on your page, you can. If you want to take 10 minutes to solve each of these problems, you can. You'll have more than enough time. All right, next up is problem number 13, all right, which I'm just going to look at from another sheet right here. So number 13, propane is burned. Now I'm going to put this in here because I don't expect you to know that propane is C3H8. I don't expect that of you guys. I just expect you to know how to use it to grill on Memorial Day weekend, all right? So propane is burned, okay? This is a combustion. Burned means combustion. And in any combustion reaction, you take the hydrocarbon, all right, C3H8, you combine it. What do you need when you burn something? You need O2. All right, the unspoken reactant here is O2 because you always need O2. And you always produce CO2 and H2O. No crisscross needed, nothing like that. All right, it's just CO2 and H2O. Those are what the products always are. Combustion reactions, very easy to predict the products, tougher to balance. So let's get to it. Okay, we've got 3 carbons over here and 1 over here, so we're going to put a 3 in front. We've got 8 hydrogens over here and 2 here, so we're going to put a 4 in front. Okay, lastly, we have 2 oxygens here and 6 right here. 3 times 2 is 6. And 4 right here. 4 times 1 is 4, for a total of 10 oxygens on the product side. So we have to multiply this by 5. There we go. This is the balanced equation right here. All right. Combustion reactions, very easy to predict the products. They're always CO2 and H2O, harder to balance. So when you balance them, first things first, always balance the carbon. All right. Then second, balance the hydrogen. Then third, balance the oxygen. Always go in that order. That'll make your life easier. All right, guys, guess what? We are on the last problem, and it's a doozy. All right, let's go for it. Problem number 14. Calcium hydroxide is mixed with phosphoric acid, aka hydrogen phosphate. Good Lord. All right, so let's go for it. All right, so calcium hydroxide. Calcium is 2 plus. I know this because it's in the second column of the periodic table. And hydroxide we've dealt with before on this worksheet. It's OH minus. So 2 hydroxides, 1 calcium. Calcium hydroxide is CaOH2. The other thing is phosphoric acid, aka hydrogen, which is H plus, and phosphate, PO4 3 minus. So we crisscross and we get 3 hydrogens and 1 phosphate, which doesn't look like this. This is a single phosphate. This is what 1 phosphate looks like. All right, very good. And now we have a reaction. So let's see here. This calcium is 2 plus. Hydroxide is 1 minus. Hydrogen is 1 plus. And phosphate is 3 minus. So let's make some new compounds. All right. Calcium is going to go with phosphate because calcium is positive and phosphate is negative. Hydrogen is going to go with hydroxide, again, because you need to have a positive and a negative ion to make a compound. So let's see here. Calcium, Ca2 plus, phosphate, PO4, 3 minus. This is a fun one. You're going to end up with 2 phosphates and 3 calcium. So the formula is Ca3, PO4, 2. The other thing that you're going to form is hydrogen is going to bond with your hydroxide. And guess what this forms, guys? This forms HOH, also known as H2O, also known as water. So you can think of it as H2O, but I'm going to keep it as HOH because it makes the reaction easier to balance. So I'm actually going to highlight it first to kind of draw our attention here, and now I'm going to balance. So 1 calcium, 3 calciums. So we got to do 3 calciums. Fine. All right. 2 hydroxides over. Oh, 6 hydroxides over here. Only 1 hydroxide here, so we got to put a 6 in front, okay? We've got 3 hydrogens here and 6 hydrogens here, so we got to put a 2 in front. And yeah, that's it. That's it. Now, another double replacement reaction. This only occurs if one of our products forms a solid, a liquid, or a gas. All right, so I'm going to go back here. Calcium phosphate. Let's take a look. Calcium phosphate. Oh, calcium phosphate is a solid. And you know what? Hydrogen hydroxide is a liquid. Water is a liquid. Any reaction that produces water is going to happen. So both of these guys cause the reaction to go. You only need one of them, but both of them make the reaction go in this case. All right, a bit of overkill. All right, guys, and I'm pretty sure that this is it. All right, awesome. I hope this was helpful, and on to the next chapter.